Okay, welcome to DET tutorial. In this video, we'll be looking at the chemical properties of methane. So methane is a typical example of an alkane. It is the first member of the alkane series, and being the first member, it is a gas. And we've already established in previous class that alkane are not very reactive. And the reason they are not very reactive is because of their degree of saturation, because they contain only single bonds and all the single bonds are fully occupied. And so because of that full occupance, it doesn't give room for reaction. But there are some reactions that alkanes can undergo, and the two basic reactions alkanes can undergo are the combustion reaction and the substitution reaction. So these are the two basic reactions alkanes can undergo. It is very important and it's very vital. It can come in an exam that which of the following reactions can alkane undergo. You should know that it's either substitution reaction or combustion reaction. So we'll be using methane as a case study in knowing the chemical properties and the chemical reactions of the alkane. So the first reaction we're going to look at is the combustion reaction. So combustion simply means, the word combustion simply means burning. And for a substance to burn, it requires oxygen. It is oxygen that enables the substance to burn. So combustion reaction is simply burning reaction, and it occurs in the presence of oxygen. So you can therefore say that combustion reaction is a reaction of any substance with oxygen. So when methane reacts with oxygen, that reaction is known as a combustion reaction. So when methane burns in oxygen, which is a combustion reaction, water is formed and carbon dioxide is formed. So all alkanes generally, when they undergo combustion reaction, two products are usually formed. Two substances are usually formed, and they are water and carbon dioxide. So this is high yield. You can be asked in an exam that when pentane, hexane, or any alkane as well, when they undergo combustion reaction, which of the following products are formed? It's water and carbon dioxide that are formed. So when one molecule of methane reacts with two molecules of oxygen, two molecules of water, and one molecule of carbon dioxide is formed. So this equation is very important. So for you to be able to write a balanced equation, you need the formula for the general equation of combustion reaction of alkanes. And this is the formula for the general equation for the combustion reaction of alkanes. You have CXHY, which symbolizes the alkane, plus X plus Y over 4O2, which symbolizes the number of moles of oxygen, which will result to Y over 2 molecules of water and X molecules of carbon dioxide. So whatever you have here as your X is what you will put here. If you have 5 here, you put 5 here. So we will look at this equation more vividly in another video. So the main important thing to know here is that when alkanes react with oxygen, water and carbon dioxide is formed. So this is methane, a typical example of the alkane series. So when methane reacts with oxygen, two molecules of oxygen, two molecules of water is formed, and one molecule of carbon dioxide is formed. So having known this, let's look at the other reaction that alkanes can undergo, which is the substitution reaction. So to substitute simply means to replace. Just have this at the back of your mind, that to substitute means to replace. So this is also called replacement reaction. So what is substitution reaction? Substitution reaction is a reaction in which there is displacement of an atom or group of atoms by another atom. So one atom will displace another atom in this reaction. So alkanes generally, they undergo substitution reaction with halogens. So the halogens can be fluorine, it can be chlorine, it can be bromine, and it can be iodine. But basically, most substitution reactions are with chlorine. So we are going to look at a substitution reaction of an alkane by a chlorine molecule with a chlorine molecule. So this is a typical example of the substitution reaction of methane with chlorine, and this reaction is referred to as chlorination of methane. So this is methane, this is the structure of methane, and this is chlorine. So when methane reacts with chlorine, what the chlorine does is that it will displace hydrogen from this methane. It will displace one hydrogen from this methane and form a compound known as chloromethane. So you can see this chlorine here that has displaced the hydrogen and has replaced its position, and hydrogen chloride will also be formed. So this is what substitution reaction is about, substitution reaction. So it is the displacement of an atom by another atom or group of atoms. So if we put that here, you can see that this chlorine is displacing this hydrogen from the methane to form chloromethane. This is a condensed representation of what we have here. So this is methane reacting with chlorine. When methane reacts with chlorine, the chlorine will displace one hydrogen from this chlorine to form what is called chloromethane. So we have CH3 instead of CH4. One hydrogen has been displaced to get CH3, then Cl, which is called chloromethane, and hydrogen chloride will be formed. So like I've said, when methane, this is methane, when it reacts with chlorine, substitution reaction is certain. The chlorine will displace one hydrogen to form chloromethane and hydrogen chloride. So in the presence of more chlorine molecule, this chloromethane that has been formed will further react with another chlorine. So this is the reaction. This is the chloromethane further reacting with chlorine molecule. So when chloromethane reacts with chlorine, the substitution reaction will still occur. Chlorine will displace another hydrogen from this chloromethane to form dichloromethane. So here we have 3 hydrogen. After the substitution reaction, we are now having 2 hydrogen and 2 chlorine. So chlorine has displaced another hydrogen to form dichloromethane, and hydrogen chloride will be formed. Also, in the presence of more chlorine molecule, this dichloromethane that has been formed will further undergo a substitution reaction with chlorine as represented here. So this is the dichloromethane that has been formed. It will now further react with chlorine to form trichloromethane. So it has displaced one hydrogen from this dichloromethane already to form trichloromethane. So, and hydrogen chloride, which is formed alongside. In the presence of more chlorine molecule as well, this trichloromethane that has been formed will further react with chlorine, and this chlorine will displace the remaining one hydrogen from this compound to form tetrachloromethane, and hydrogen chloride is formed. So the reaction will continue in the presence of more chlorine. It will continue until all the hydrogen in the methane has been replaced. So you can see finally here that all the hydrogen atoms, they have already been replaced by chlorine molecule. So one important thing to know here is that this reaction can occur spontaneously under the ultraviolet light. So this reaction can occur spontaneously under the UV light, under ultraviolet light. That means that this reaction can actually occur on its own under the influence of this ultraviolet light. So if you observe this reaction closely, you will discover that chlorine is always displacing the hydrogen from the atom. chlorine displaces hydrogen from methane, chlorine will displace hydrogen from chloromethane, chlorine displaces hydrogen from dichloromethane, and chlorine displaces hydrogen from trichloromethane. So what is the reason why chlorine will displace hydrogen from methane? So the reason why chlorine displaces hydrogen from methane is because chlorine is more electronegative than hydrogen. So this is a very important fact, and it can come as a question: why does chlorine displace hydrogen from methane? It is because chlorine is more electronegative than hydrogen. So being more electronegative than hydrogen, it simply means that chlorine has a higher affinity for electrons. It has higher affinity for electrons, and because it has a greater affinity for electrons, that will result in the transfer of hydrogen from methane to chlorine. So if we observe this reaction very well, you can see that there is transfer of hydrogen from this methane to chlorine to form hydrogen chloride. Then there is transfer of hydrogen as well from this chloromethane to this chlorine to form hydrogen chloride. So that stronger affinity that chlorine has, that more electronegativity, is what is responsible for the transfer of hydrogen from the methane to chlorine and from chloromethane to the chlorine to form hydrogen chloride. So having known all this, let's look at the importance of methane or the uses of methane. So one of the uses of methane is that it is used as a source of fuel. Methane is a component of natural gas and is widely used in heating, in cooking, and even in generating electricity. So one of the importance of methane is that it is used as a source of fuel for heating, for cooking, or for generating electricity. And secondly, methane is used in production of water gas. Water gas is a mixture of carbon monoxide and hydrogen. So this water gas is also very vital. It is used as a source of fuel, and it's also used in generating electricity. That is, it is used in producing electricity, and also it can be used in production of different substances like ammonia. So the water gas is very important. So one of the use of methane is that it is used as a source of fuel. Secondly, it is used in production of water gas. Then thirdly, methane is used in making hydrogen, alkyne, trichloromethane, and tetrachloromethane. So these substances, they are very vital. For example, trichloromethane is used as an anesthetic in surgical operations. This is very vital, and it usually comes very often in exam. You can be asked that which of the following products can be used as an anesthetic in surgical operations. You should know that it is trichloromethane. An anesthetic is that substance that is used to cause loss of consciousness in a patient during surgical operation. So trichloromethane is an example of an anesthetic, and it is very vital. Then the other compound we have here is the tetrachloromethane. Tetrachloromethane is a very useful organic solvent in industries. So tetrachloromethane can be used as an organic solvent, in industries. What does that mean? It means that it can be used as a solvent for dissolving organic substances in industries. So it is very vital too. It comes very frequently in exam as well as a question, that which of the following can be used as an organic solvent in chemical industries? Know that it is tetrachloromethane. So while trichloromethane is used as an anesthetic in surgical operations, tetrachloromethane is used as an organic solvent in chemical industries. So these are the basic uses of methane. It is used as a source of fuel for heating, for cooking and generating electricity. It is used in production of water gas, and water gas, like I said, is a mixture of carbon monoxide and hydrogen, and this substance can be used in generation of electricity. It can also be used in producing chemical substances like ammonia. Then the third use of methane is that it's used in making hydrogen alkane, trichloromethane and tetrachloromethane. And I've said that trichloromethane is used as an anesthetic in surgical operations, while tetrachloromethane is a useful organic solvent in chemical industries. So with this, we are done with this class.